friends. Today you are going to study the cubic lattices. In that one, how to know the lattice points or number of atoms in a given unit cell. And also today you are going to study how to determine the planar densities. How to determine the planar densities in a given simple cubic systems, body-centered systems, and also the face-centered systems. So first of all, let's focus on these main three cubes. So if you think this is the simple cubic system, normally in simple cubic systems there are 8 atoms in the corner. In simple cubic systems there are 8 atoms in the corner. So now we want to find out the lattice point or number of atoms in a given unit cell. Actually the unit cells means, it is the smallest repeating unit for a crystal. It is the smallest repeating unit for a crystal. So for this simple cubic system, you can see 1/8 of the atom is shared into the cube. Why it is? All the atoms are oriented, all the atoms are located in the corner. At the same time, there is another cube this side and another cube this side. So altogether 4 cubes are around inside a one atom. So only 1/8 is shared into the cube. So the sharing is 1/8 and you have 8 corners. So the lattice point will be 1. Or it is 1 atom. Or you can say number of atoms in the given unit cell is 1. So this is for simple cubic system. And if this is BCC structure or the body-centered cubic structure, here also 8 atoms are in the corner. 8 atoms are in the corner. Only the difference is there is a one blocked atom. There is a one blocked atom in the middle. So here also, when we are going to find the lattice point, from each 8 corners, you can calculate the sharing 1/8 into 8. And there is an atom, blocked atom in the middle. So the number of lattice point is 2. So this is for BCC structure. Then if you think about the FCC structure, this is your FCC structure, that is face-centered cubic structure. Here also 8 atoms are in the corner. In addition to that, in the face-centered cubic, there are 6 atoms in the face. For this face 1 atom, for this face 1 atom, here also 1 atom in the middle, here also 1 atom in the middle, and for this side another atom, for this side another atom. So likewise 6 atoms are in the each sides or the each planes. So how to calculate the lattice point? Here also by corners you can find out the value 1/8 into 8. Just looks like it is simple cubic. Then only the difference is here in the face there is a 1 atom. But inside the cube only half of the atom is going to be shared. Then other half is going to be in the next adjacent cube. Here also half of the atom is going to be shared inside the cube. So half into there are 6 atoms are in the unit cell. So your value will be 4. So finally we can say for a simple cubic system, lattice point is 1. For body-centered cubic, it is 2. And for the face-centered cubic, the lattice point or the number of atoms in the unit cell is 4. Here, this is a primitive lattice and this is a non-primitive lattice. And here, this one also non-primitive lattice. Because the reason is, in the primitive lattice, that may contain only one lattice point. But in non-primitive lattices, you can see more than one lattice point. That is why here we have 2 and 4 more than one lattice points. That's why these are non-primitive unit cells. So now we can easily find, if you know these things, if you know the lattice points, you can find out the planar densities. So now let's see how to find out those planar densities, because I have already discussed with you how to draw the Miller indices. That means 1, 0, 0 plane, 1, 1, 0 plane and 1, 1, 1 plane. I have already explained you in the previous video. So now we can find out how to calculate the planar densities in that given simple cubic, body-centered and face-centered structure. So let's move on to that. This is the simple cubic system, and here we can name the edge length is A. Here also edge length is A, and for this one also we know edge length is A, because this is made up of squares. So we know 8 atoms are in the corner of simple cubic unit cell. So if you focus on these 2 atoms, we can write it here. It just look like this. It is look like this. These are the atoms we focus. So we know the radius of the atom is r. We know the radius of the atom is r. Now we are going to calculate the planar densities in terms of r, not a. So we need an expression in terms of r for this a. So this length is the radius r. Here also this length is the radius r. So simply you can say, for a simple cubic system, this A equals to 2r. So likewise, let's see how to determine the edge length for a body-centered cubic structure. In case of body-centered structure, we know 8 atoms are in the corners, and also there is a block atom in the middle, like this. So in this case, if you think about the atoms in this diagonal, this atom, and also this atom, we can just write in this cube. So this is your middle atom, and also these are your other atoms. These are your other atoms. So this is the 3 atoms I already told. this atom and this atom which is in the diagonal. These three are having the same area. And if you think about this one, here we know the length is 2r. Here the length is r. Here also the length is r because of the radius. And here we know this length is a, this length is also a. And now we are going to find this triangle. If I number this as A, B, C and D. So in terms of A, B, C and D, you can construct a expression. Here AD squared is equals to AC squared plus ACD squared. AC squared plus CD squared. The reason is here the angle is 90 degrees. So AD squared equals AC squared plus AD squared by using the Pythagoras law. Here AD squared equals to 4r. Here r, 2r and here also r. So it is 4r squared. Here AC squared can be written in terms of AB squared plus BC squared, because here also the angle is 90 degrees. So for this one also we can use the Pythagoras law. So this is AB squared plus BC squared and here CD squared. And for this we know the length is A. Here also the length is A. So A squared plus A squared plus here CD also we know A squared. So here your answer is 16r squared 3a squared. So now you can write 16 over 3r squared equals a. So your answer is 4 over root 3 r. So the value of a is 4 over root 3 r. So likewise we can calculate the edge length for FCC structure also. In case of FCC structure, here also 8 atoms are in the corner and also 6 atoms are in the faces. 6 atoms are in the faces. And if you take this face, you can say 4 atoms are in the corner and 1 atom in the middle of the face. So here you can write like this. So 4, here the middle atom is like this, then 1/2, here also 1/2 and here also quarter of the atoms are going to be shared. So now you know this length is r, this is 2r and here also r. And this length, the edge length is a, this one also a. For this case also we can use the Pythagoras law for this triangle. So 4r squared is equals to a squared plus a squared. So 16r squared equals 2a squared. So it is 8r squared is equals to a squared. So the value of a is 2 root 2r. Here 4 into 2, the value of the root 8. From that you can get 2 root 2r. So these things you need to know. So now we can get some expressions in terms of r for the planar density. So let's look at how to solve those things. We are going to find out the planar densities for simple cubic structure for the given plane 1, 0, 0. So I already explained you, this is the 1, 0, 0 plane in the Miller indices section. So we already know the edge length A is equals to 2r. So if we take this face, you can see that it looks like this. And we know quarter of the sphere is going to be shared. So likewise, quarter of the sphere is going to be shared. So the length is A, here also the length is A. For this one the length is R. We already know that. So from that you can get the planar density. So for the equation for the planar density, or number of atoms in centimeter minus 2 square, that is number of atoms in the plane, over area of the plane. Number of atoms centered on the plane over area of the plane. That is the number of atoms in centimeter minus 2 squared, or the planar density. So first, let's find out the area of this 1, 0, 0 plane. So the area of the plane equals to A into A. Here A into A. That is A square. Here A means 2R. That is 2R square. So your answer is 4R square. Now the planar density equals number of atoms centered in the plane. Here you can see 1 over 4 into 4 atoms are shared in the plane. That means 1 over 4 into 4 atoms are shared in the plane. Here the area of the plane 4R square. That equals 1 over 4R square. So this is your answer for number of atoms for centimeter minus 2 square. This is your simple cubic 110 plane. So from this plane we can draw the rectangle like this. So here also 1 over 4 atoms going to be shared. 1 over 4 atoms going to be shared because there are 4 atoms in the corner. You can write like this. Then if I number this length as B, this length also B. Here we know this length is A, this length also A, and this length also A. So here also this length is A. Now we want to find what is this B. Here B squared equals A squared plus A squared. So 2A squared. Here we know A equals to 2R. So 2R squared. Then we can write into 4R squared. So your value B will be 2 root 2R. Then your value B will be 2 root 2R. So the area of the plane A into B. The area of the rectangle A into B. So now we can write here A means 2R. Here B means 2 root 2R. So 2 into 2 is 4 root 2R squared is your answer. Now we can find out the planar density. So your planar density equals number of atoms centered on the plane. Here 1 over 4 into 4 atoms are shared. So 1 over 4 into 4. Here the area is 4 root 2 R square. So your answer will be 1 over 4 root 2 R square. So likewise, we can find out the planar density for simple cubic 111 plane also. So let's look at that. This is your simple cubic 111 plane. Here also this length is A, this length is B. Here also this length is B. For this one also the length is B. For this triangle. Anyhow, this is equilateral triangle. That one you can see. So we can take that triangle like this. So here likewise the atoms are going to be shared. Here actually 1 over 6 is shared from one atom. So this is your length B. So this half is B over 2. This half also B over 2. And this is B. And this height is H. Because we need this height because we are going to find out the area in a triangle. So we have already found the value of B in the previous one. We know B equals 2 root 2 R. By using the Pythagoras law, B squared equals A squared plus A squared. Now we want to know the value of H. Here also we can use the same Pythagoras theorem. Here B squared equals B over 2 squared plus H squared. So B squared equals B squared over 4 plus H squared. So the H squared will be B squared minus B squared over 4. So the value will be 3B squared over 4 into the root. So this is the value of A. Now we can find out the area of the triangle, half into length of the base, it is B, into the perpendicular height, that is H. So half into, here B means we already know 2 root 2 R, into H means here root 3 B over 2. Again we can find into 2 root 2 R root 3, again B equals to 2 root 2 R over 2. From this we can say here the value is 4, here 2 into 2, that is 4, here 2 into 2, that is again 2, here root 3 is there, then R squared will come. So your value is 2 root 3 R squared. That is your area. So let's find out what is the planar density. We want to find out the planar density. That is number of atoms centered on the plane. Here for this plane, you know 1 over 6 into 3 atoms going to be shared. 1 over 6 into 3. Here the area is 2 root 3 R squared. So you can get here half into 2 root 3 R squared. From this you can get 1 over 4 root 3 R squared. So this is the number of atoms per centimeter minus 2 square. So this is the planar density for simple cubic 111 plane. So likewise we can find out the planar density for BCC structure and also FCC structure. BCC 100 plane, this plane. So here I can draw like this square. Here also 1 over 4 into 4 atoms going to be shared. And here also we know the length is A. Here also the length is A. So this is also A. This is also A. So your area is going to be A square. But we already calculated the value of A for BCC cubic structure is 4 over root 3 R. So that is square. So from this you can find out the area of the BCC structure. Then you can directly go to the planar density for this BCC plane. That is number of atoms centered on the plane. That is 1 over 4 into 4. That is 1. So 1 over 4 into root 3 R squared. Likewise, in the same as the previous example, you can find out the planar density. This is your BCC 110 plane. Here this rectangular plane is your 110 plane. Here we can number this as B, this length, here also A, here also A. So from the Pythagoras theorem we can get the value of B as root 2A. We have already proved that. And so this length will be B and this length will be A. So number of atoms going to be shared here 1 over 4 into 4 plus again another 1 atom is going to be shared. So altogether number of atoms is equals to 2. Then you can find out your planar density. Planar density, it is 2 over the area. Area means A into B. Here we know the value of A. that is 4 over root 3r, and here we know the value of b also, that is root 2 into a. So likewise you can get the planar density for BCC 110 plane. Your BCC 111 plane, here this triangle, here also we know the length A, here also B, because of the equilateral triangle this is also B and this is also B. So here all lengths are B, B, and here also B. So now we can divide this into 2, B over 2, here also B over 2, and this height will be h. For the area, you want to find out the area of this triangle. Here also we already know by using the Pythagoras theorem, we can get the value of b, that is a squared plus a squared. So b will be root 2a. Then you can get the value of h also by using Pythagoras theorem. Here b squared equals b over 2 squared plus h squared. So you can get the value of h. Here the value of b is given, and also the value of a we have already found. So then you can go up to how to calculate the planar density. So this is the planar densities for BCC structures. Likewise, finally you can focus on how to find the planar densities in FCC structures. So it's the FCC 100 plane. Here the only the difference is the atoms are placed on the faces. So from this we can get this plane like this. Here also 1 over 4 into 4 atoms are shared in the plane. And also in the face there is one atom completely. So this length is A, here also the length is A. So the area of the plane is A square. For FCC structure, the value of A in terms of R is already proved. So you can substitute into here and find out the value. So number of atoms equals, that is 1 over 4 into 4 plus 1, that is 2. So from this you can directly go for the planar density, that is 2 over A squared. So you can find out the value for FCC 100 structure. In the case of FCC 110 structure, your plane is like this, such a rectangle. Here you can see this B atom and also D atom is in the faces. So from this we can write the shape like this. Here also A, B, C, D, E, F atoms are oriented like this. And normally face-centered structure is a close-packed structure. So this is also R, this is also 2R, and this is also R. So the value of AC will be here 4R, because this is also R, this is 2R, and this is also R. And the value of AD will be, it is A, the length of this one, this is A. So the value of A is already proved 2 root 2R. So the area will be AC into AD. So from this you can directly find out the area. If you think like the number of atoms going to be shared, that is here 1 over 4 is going to be shared. Here also 1 over 4. Here also 1 over 4. Here also 1 over 4. And here half half. So altogether 2 atoms are going to be shared. So 2 over the area AC into AD. Directly you can find the planar density. So then let's focus on FCC 111 plane. So in the case of FCC 111 plane, here it is the plane. Here you can see one atom in the face, another atom in the face, and this atom. These 3 atoms are shared into the plane, and the corners, another 3 corners are shared. So altogether 6 atoms are shared. So we can write like this, and this is the triangle we can write. So here also we know this is A, this is A, this also B, this also B, and this also B. Anyhow, this is the length R, this is 2R, this is also R. So if you think the perpendicular height, it is H, and your base, that is 4R. So you can find out the area. Here first you need to know what is the value of H. By using the Pythagoras theorem, here the value is 2R. So 2R squared plus H squared, that equals to this value. Here also R, this is 2R, this is again R. So 4R squared. So from this you can find out the value of H. Then you can find out the area, half into the length of the base, that is 4R, into height, that is H. So this is the area. So finally, how many atoms, or the number of atoms are centered on the plane? Here 1 over 6 is shared. 1 over 6. Likewise here also 1 over 6, here also 1 over 6. That is 1 over 6 into 3. And here 3 halves are shared. So that is also 1 and half. So altogether 2 atoms are shared on the plane. So likewise finally you can go to the planar density calculation. So this is how the calculations are going on for FCC structure, and just like previous BCC structure and simple cubic structures. These are the things I wanted to discuss with you today. The lattice parameters, and also finally we wrote the planar density, those kind of things. So in the upcoming video we want to focus on the Bragg's angle and also the X-ray diffraction. So please work with these examples, then you can feel much easier in your exams. So thanks for watching.